Welcome to Who Wants to Be a Mathematician? I'm your host, Mr. Hill. Today we're going to be talking about tangent lines of graphs. And this is the start of calculus. This is when the rubber meets the road. We've just been building up our toolbox to get up to this point. So this point, what do we want to do? We eventually want to find out what is the slope of a curve. But you can't really find the slope of a curve because if I do rise over run here, that's going to give me the slope of a straight line, right? It's not going to give me the slope of a curve. So the whole point, we're building up to finding the slope of a curve. And how we're going to do that? We're going to start by finding slopes of the curve at a certain point. Not the total curve, just the curve at a certain point. So if we have right here one point on our graph, and we can find the slope of that point. Well, what is that line called? It meets our graph at exactly one point. Well, if you're a betting person and we're talking about tangent lines, you may want to say it's a tangent line, and you'd be correct. A tangent line meets the graph at exactly one place. So we're going to start off by finding slope of tangent lines. So we want to find the slope of the tangent line at A. This is our end goal. Our end goal is to find this slope. How are we going to get there? Well, we don't really have any coordinates for that, and we don't really know rise over run. I mean, we can look at the graph paper and figure it out, but if you didn't graph it, or if the parabola was a little bit different or in a funky spot, or the slope wasn't even, how would we figure it out? Well, we're going to start off by finding the slope of the secant line. In the secant line, you take 2 points. We're going to call them, let's do this. Oh, that wasn't what I know. Okay. All right. So x and f of x. So if you just think of it, x is your x-coordinate, f of x is your y. Makes sense. So x and f of x is going to be there. And we're going to have a and f of a and f of a. And the secant line is going to be a line that goes through these 2 points. Now let's see if I can get this right. I'm going to have to get rid of my tangent line real quick because it's confusing me. Oh, that's not what I wanted. Oh, come on. Come on, Mr. Hill. Get it together. All right. So we have our secant line. And what is the slope of that secant line? Well, any slope is going to be rise over run. So what did we rise? And how far did we run? Well, our rise, so slope is m, subscript s, slope of our secant is equal to our rise. And our rise is just going to be the difference between those two, and our run is going to be the difference between the other two. So where did I get that from? I said I started down here and I rose up. How do I find that? Well, I just subtract off f of a of f of x, and that's this distance. So rise is equal to f of x, minus f of a. And how did we find our run? Well, it's the same way. We find it's going to be x minus a. The distance between these two is going to be x minus a. So our slope of our secant line is going to be f of x minus f of a all over x minus a. We found our secant line. All right, so now let's move on to finding the slope of the tangent. So once we have slope of a secant, we can kind of work with it. We have a starting point. And if we have a starting point, then we can move on. So let's move on, and we have our tangent lines. So if we have our tangent lines, what we're going to do is we're going to find out when our secant line approaches our tangent line. So if we have a bunch of different secant lines, and we're making our box smaller and smaller and smaller and smaller, we're eventually going to get down to the point where we have just our tangent line left. And what is that point? Well, that point is going to be a new point. So we labeled our distance here as h, And this here is going to be just the f of a plus h minus our f of a. Same thing. So we just changed up, instead of calling this x, we replaced x with a plus h. So what we did was change it. So we want to find when this box, our f of a plus h and our a plus h, approaches a. So that happens when our h is going towards 0. So going towards 0, we're talking about a limit. So the limit as h approaches 0 of our slope will give us the slope of the tangent line. So the slope of our tangent line is going to be the limit as h approaches 0 of our slope of our secant. So the slope of our secant, as we write it out new, is going to be f of a plus h minus f of a all over a plus h minus a. So our slope of our tangent line is going to be equal to our secant line as it approaches that point. So that's why we have a limit. As our function, as our function dot approaches our a, then the limit of our slope will approach the tangent line. So what does that mean? That means that this limit here is going to be the slope of our tangent line. But we can simplify it a little bit more. If we look down at the bottom, we have a positive a, we have a negative a, they go away, and all we're left with, the slope of our tangent is equal to the limit as h approaches 0 of our rise over our run. So our rise over our run, we just found our rise and our run. So this is just a slope, and the slope of our tangent line is going to be the limit of our secant slope as it approaches 0.